Hello, everyone. This is Notes for 7C. This is the lesson Notes for 7C. So, ladies and gentlemen, we're going to learn how to do something that's called scientific notation. And what we're going to do right now is I've got to start by talking to you about multiplying numbers by 10. So if you remember when you were in elementary school, you learned that if you took, say, the number 3 and multiplied it by 10, let me make that a little bit bigger. You would add a 0 and you would get 30. If you multiplied by 100, you would add 2 zeros and get 300. If you multiplied by 1,000, you would add 3 zeros and get 3,000. Now, what I need to explain to you is that when you multiply by 10, that's actually multiplying by 10 to the first. When you multiply by 100, that's actually multiplying by 10 to the second power. And when you multiply by 1,000, that's actually multiplying by 10 to the third power. Now, I want you to look at this. 10 to the first, we added 1 0. 10 to the second, we added 2 zeros. Multiplying by 10 to the third, we added 3 zeros. Now, when you were taught this, when you were in elementary school, you were using only whole numbers, no decimals. But now you're in 8th grade, and so you're older, and we're going to have decimals. So technically, you were doing something besides adding a 0. What you were doing is moving the decimal point. So if you have the number 3, that is the same as 3 point. Remember that when the decimal point doesn't show up, it's at the end of the number. So if you're multiplying by 10 to the first power, what you're doing is you are moving the decimal one space. Then if you have 3 times 10 to the second power, you have 3 point, and you're moving the decimal point 2 spaces. If you have 3 times 10 to the third, you have 3 point, and you're moving the decimal point 3 spaces. So when you were taught in elementary school, add a 0, that wasn't wrong. It's just that what if the number is a decimal? Well, if the number is a decimal, what you're actually doing is you're moving the decimal point that many spaces, okay? So now the next thing I need to talk to you about is why we have something that's called scientific notation. So ladies and gentlemen, there are some people that have to use numbers that are just huge numbers. So let's start with the number 1,000,000, 1,000,000. So I can write it as 1 and then the word million, okay? Or I can write it as a 1 followed by 6 zeros. Actually, you know what I should do? I should put it here. 1. Okay, now let's do a billion. 1 billion is a 1 with 9 zeros. Okay, what's a trillion? 1 trillion is a 1 with 12 zeros. Okay, now look at that number, 1 trillion. That is a huge number. So if you are a person that has to work with these humongous numbers, you don't want to have to write out all of those zeros all the time. It takes too long. So you need a shorter way to write the number. And that's where scientific notation comes in. Scientific notation is a shorter way to write a number. So if I wanted to write the number 1 million, okay, I would write it as 1.0 times 10 to the 6th. So now I don't have to have the 0.0, but I want to show you that because You're moving the decimal point. So how did I know that it was 10 to the 6th? Because there's 6 zeros right there. And then a billion would be 1.0 times 10 to the 9th. How do I know it's 10 to the 9th? Because there's 9 zeros there. And then a trillion would be 1.0 times 10 to the 12th. Again, because there's 12 zeros. Now, I want you to think about something. If you have been paying attention to your parents over the last few months since COVID, well, actually the last year, since COVID started, the government has sent out stimulus checks. 3 times now, our families have all gotten stimulus checks. So the last one was a $1.9 trillion package. 1.9 trillion. Well, how do I write the number 1.9 trillion? $1.9 trillion is going to be a 1,900,000,000,000,000. Okay, that's how big, almost 2 trillion, but not quite. Every person got $1,400 from the government. So the government sent out checks to everybody for $1,400. So if you have a mom and a dad at your house, you guys got $2,800 from the government just recently, which is really helpful, especially for people who have lost their jobs. Now, how do you write that in scientific notation? Well, I have to think about what scientific notation is. So the scientists that came up with this, because they needed a way to write really, really, really big numbers quicker, they came up with 3 rules for scientific notation. So the first rule is that it has to be a number between 1 and 9. Second rule, it has to be times 10 to a power. And the third rule is that the exponent cannot be a fraction or a decimal. Okay, so if I want to make 1.9 trillion, this huge number right here, if I want to make that into scientific notation, I don't see a decimal point. I see a bunch of commas, but I don't see a decimal point. Remember that if you don't see a decimal point, it's because it's at the very end of the number. Now, I need to move the decimal point so that my number is between 1 and 9. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. Now, do you notice that I put it in between the 1 and the 9? So that is 1.9 times 10. And how many times did I move the decimal? I moved it 12 times. So 1.9 trillion is the same as 1.9 times 10 to the 12th. And I want you to notice how much quicker it is to write that than it is to write this. That's where scientific notation comes from. Okay, now, I need to show you, before we go in and start our lesson, I need to show you how to take a number that's in scientific notation and write it as a standard number, okay? So say I give you the number 2.3 times 10 to the 5th power, okay? And that's in scientific notation. 2.3 is between 1 and 9. It's times 10, and the exponent does not have a decimal or a fraction. So now what I do is I go 2.3, and then I move the decimal 5 times. Now, did you notice that my exponent is a positive 5? If the exponent is positive, then it means that your number is going to get bigger. So you have to go to the right. So 1, 2, 3, 4, 5. Now, that's your decimal point now at the end. Notice that I made a bunch of waves. in each wave, you're going to put a 0 that doesn't have a number. You're going to put a 0. So it equals 230,000. Okay? Okay, now, what if I have a number that is in standard form and I want to put it in scientific notation? So what if I have the number 45000, okay? And I want to put that in scientific notation. So my decimal point's at the end, and I have to move it until I have a number between 1 and 9. So I have to move it in between the first two numbers. So 1, 2, 3, 4. So notice I moved it 4 times, and now I have 4.5 times 10 to the 4th. Why is the exponent 4? Because I moved the decimal point 4 times. So look at your waves. That's how you know. Okay, now the last thing that I need to talk to you about is small numbers. What if instead of the number being really big, what if the number is really, really tiny? Well, if the number is really, really tiny, then the exponent is going to be a negative number. So think about this. What if I have 7.8 times 10 to the negative 6? So notice that my exponent is a negative number instead of a positive number. If my exponent is negative, it means that the number is going to get smaller. So I write the 7.8, but I put it off to the right, and then I move the decimal point 6 times, but to the left. So 1, 2, 3, 4, 5, 6. And then I fill zeros in all of the empty waves. So that number is now 0.000078. So this decimal point isn't there anymore. I moved it. So it's 0.000078. That is my number. Okay, finally, what if I have a number, but it's a small number, and it's in standard form, and I want to put it in scientific notation? So say I have 0.00603, and I want to put that in scientific notation. So I have to move the decimal again until I have a number that is between 1 and 9. So I have to move the decimal to the right this time because I have to make the number a number between 1 and 9. So I need to move it until the first number that's not a 0. So I'm going to move it 1, 2, 3 times. So it equals 6.03 times 10 to the negative 3. Why is it negative 3? Because I moved the decimal 3 spaces. Why is it negative, though, and not positive? Because the number is small. When the number is small, your exponent's going to be negative. When the number is big, the exponent's going to be positive. Okay, now we're going to go to My Open Math, and we're going to start our lesson. So this is Notes for 7C, and this is number 1. So it says, which of the following demonstrates the correct conversion into scientific notation? So remember the rules, okay? It has to be a number between 1 and 9. It has to be times 10 to a power. And the exponent cannot be a fraction or a decimal. Okay, now we start with the very first one. So notice that we have 6.05 times 10 to the 5th. Is 6.05 between 1 and 9? Yeah. Is it times 10? Yes. Is my exponent not a decimal or fraction? It's good. We're all good. But now I need to know, is this 5 the correct number? So what I'm going to do is in my work area, I'm going to write 6.05 times 10 to the fifth. Okay? And then underneath it, I'm going to write 6.05, and I'm going to move the decimal 5 times. Now, the exponent's positive, so I'm going to move it to the right. 1, 2, 3, 4, 5. Put in my zeros. And now I'm going to compare. Is this number the same as this number? 605000. Yes, it is. Okay, so I'm going to select this one because it worked. Okay, now I'm going to go to the next one, and it's 5 times 10 to the ninth. Okay, 5 is between 1 and 9. It's times 10, and the exponent is not a decimal or a fraction, so I'm good. But now I need to figure out if this 9 is the right number. So it's 5 times 10 to the ninth. So 5 point, remember the decimal points at the end. And because the exponent is positive, I move it to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put zeros in all the empty waves. Now I compare. Is this number the same as this number? And yes, it is, because it has 9 zeros. So it is right, and I select it. Now I go to the next one, and the next one is 0.21. Okay, whoa, wait a minute. That is not between 1 and 9. 0.21 is less than 1. So no, nothing in the work area. That doesn't work. Now I look at the next one, and the number is 91. That's not between 1 and 9. That does not work. Cross it out. So notice we didn't have to put anything in the work area for those. Okay, the next one is 5.1. That's between 1 and 9 times 10, and the exponent is not a decimal or a fraction, so I'm good. But now I have to figure out if the 5 is a correct number. So 5.1 times 10 to the fifth. So 5.1, and then move the decimal 5 times. 1, 2, 3, 4, 5. Okay, put zeros in the empty waves. Now, does this number match this number? No. So the one in my work area has 4 zeros, but the one on the problem has 5 zeros. No, don't select it. Okay, now we go down to the next one. 2.77, yeah, that's between 1 and 9. Times 10, yeah. My exponent is -6, not a fraction or a decimal, so that's good. But now I need to know if the -6 is the right number. So 2.77 times 10 to the -6. Okay, now I'm remembering from what I just talked about that if the exponent is a negative, I have to move it to the left. So I'm going to write the 2.77 off to the right, and I'm going to move it 6 places left. 1, 2, 3, 4, 5, 6. Put zeros in all of the empty waves. Now we've got to compare. Is that the same? So I'm going to look at my zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes! They match. So I'm going to check it. And finally, I'm on the last one, 4.82. Okay, that's between 1 and 9, times 10. The exponent's not a decimal or a fraction. But now I need to know, is that -4 the right number? So 4.82 times 10 to the -4. Okay, I remember if it's negative, I got to move it left. So I'm going to go off to the right. 4.82. I'm going to move it 4 times. 1, 2, 3, 4. So 0.0004. Uh-oh. That only has 1 0. It doesn't work. Don't select it. Okay, make sure you have all the work in the work area before you submit the question. Number 2. Number 2 is going to be so nice for you. You don't have to put anything in the work area. So it says which number below is written in scientific notation. So let's start on the bottom and look at that one. Do you notice that it is between 1 and 9? It is times 10, but oh my goodness, this is a problem. Do you notice that right there, that is a decimal point in the exponent? Not correct. Don't select it. Okay? No, don't select it. Okay, now we look at the next one, 34.3. Wait a minute. That's not right. That's not between 1 and 9. Don't select it. Then we look at the next one, 0.343. Wait, that's not between 1 and 9. Don't select it. Okay, the next one better be, right? 3.43. Okay, 3.43. That's between 1 and 9. Times 10. And the exponent is not a decimal or a fraction. That is the answer. Select that one and move on. Notice there's no work in the work area for that one. Number 3. Okay, number 3 says to rewrite it in standard form. So in your work area, can you please write 9.683 times 10 to the 8th? And then equals, and then 9.683. Now we have to move the decimal point 8 spaces. And because the exponent is a positive 8, we'll move it right. So 1, 2, 3, 4, 5, 6, 7, 8. Fill in all of your zeros with the empty waves, and then you're going to type that number in. So 9683, and then how many zeros do I have? 5. Type that number in and submit. Make sure you have your work in your work area. There's not that much work, but you got to put your work in the work area. Number 4. Okay, again, they want us to put it in standard form. So 2.535 times 10 to the negative 9. Okay, now, when it's a negative exponent, I remember that I have to move the decimal to the left. So I'm going to put my equals, but I'm going to go all the way over to the right and put my 2.535. And then I'm going to move that decimal 9 times to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put all of your zeros in the empty waves. Now, that number is 0.1, 2, 3, 4, 5, 6, 7, 8 zeros. 2535. So, ladies and gentlemen, the the decimal point that was right there, it's not there anymore because we moved it. So we moved it all the way to the front. That's why there's no more decimal there. Okay, now we're going to go type it in our answer box. And then we submit. Make sure you have the work in the work area before you submit. Number 5. Okay, now, number 5 says, here's a number in standard form. You put it in scientific notation. So 25, 550, 000. So the first thing you're going to do is you're going to write the number down. Now, notice that this is a big number, and notice that there's no decimal point. Remember, if there's no decimal point, it's at the end. Now, if I'm supposed to write this in scientific notation, I have to move the decimal point so that the number is between 1 and 9. So I'm going to move it 1, 2, 3, 4, 5, 6, 7. Notice that if I put it there, I have 2.5. That is between 1 and 9. So it's 2.555. That's messy. Times 10 to the 7th. Why is it 7? Because we moved the decimal point 7 times. Why is it positive? Because the number is big. Now, when you go to type this into the answer box, 2.555, to get your times, you have to do shift 8. Shift 8 for times. Times 10 to the 7th. So don't forget, shift 8 to do times. Make sure you have all the work in the work area before you submit. Number 6. Okay, this is the same thing that we just did, but now we're doing a really tiny number. So in our work area, we have to write the number. Okay, I got to count my zeros. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 3, 7, 4, 9. Okay, now, in order to write this in scientific notation, I have to move the decimal point so that my number is between 1 and 9. So when I have a really small number with all these zeros, I move it after the first number that's not a 0. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So notice that I moved it till after the 3 because that's the first one that's not a 0. So it's 3.749 times 10 to the negative 8. Why is it negative? Because remember, this is a small number. When the number is small, the exponent's going to be negative. Now we go type it into the answer box. 3.749. Okay, when you go to do times, you have to do shift 8. Times 10 to the negative 8. Make sure you have all the work in the work area before you submit. Number 7. Okay, number 7 is kind of weird. It gives us this number that's not in correct scientific notation and says, make it correct. So the first thing that we have to do is we have to write the number that they gave us. So 15 times 10 to the 6th. Okay? Now, do you notice that there's no decimal point on the 15? That's because it's at the end. So 15, that's your decimal point. Now, it's times 10 to the 6th, and it's a positive 6, so we're supposed to move the decimal to the right. If the exponent is positive, you move the decimal to the right. So I'm going to move it to the right 6 spaces. 1, 2, 3, 4, 5, 6. And then I'm going to put my zeros in. So remember that that is not the exponent anymore. I keep saying exponent. That is not the decimal point anymore. Now it's over here at the end. Okay? Now, our job is to put it in scientific notation. So now I have the number that's in standard form, 150000000, and my decimal point's at the end. So I need to move the decimal point so that I make a number between 1 and 10. So I have to move it in between the first and second numbers. So 1, 2, 3, 4, 5, 6, 7. So it's going to be 1.5. See how now it's between 1 and 9? Times 10 to the 7th. So we come up here, 1.5. Remember, times is shift 8. Times 10 to the 7th. Make sure you have the work in the work area before you submit. Number 8. So number 8 is the same thing. They're saying this isn't correct. Put it in scientific notation. So we start out by writing the number 0.0027 times 10 to the negative 4. Now I remember that when it is a negative exponent, we have to move the decimal to the left. So I'm going to write the number over off to the right, 0.0027. Now, I have to move it left 4 spaces because that's the exponent. 1, 2, 3, 4. Put your zeros in the empty waves. Remember, that's not your exponent. I keep saying exponent. That's not your decimal point anymore. It's all the way over here now. So our number is 0.0000027. Now I have to put it in scientific notation. So I have to move the decimal to make a number between 1 and 9. When you're looking at a really small number, notice that you have all these zeros. You want to move the decimal point until it's after the first number that's not a 0. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So I moved it 7 times. So it's 2.7 times 10 to the negative 7. So now I come up here, 2.7 times 10 to the negative 7. And then I submit. Remember, when you have to do times, it's Shift 8. Okay, now you are ready to do the assignment 7C. Have a great day, and I will see you in class.